Welcome to Brennan University. In this episode, we'll cover the characteristics, applications, and advantages of instrumentation ball valves. Instrumentation ball valves are widely used in process measurement and control systems in food and beverage, medical equipment, transportation, chemical processing, water treatment, and oil and gas industries. Popular ball valve designs are available in stainless steel and brass and incorporate one-piece packing for clean and accurate samples, as well as designs that allow for a drop-in fit for easy replacement of the packing. Brass instrumentation ball valves are rated for pressure up to 3,000 psi and temperatures to 350 degrees Fahrenheit, while stainless steel instrumentation ball valves are rated for pressures up to 10,000 psi and 450 degrees Fahrenheit. A ball valve consists of a ball-shaped component containing a port through its center to stop or start fluid flow. Flow occurs when the port is aligned with both ends of the valve. In terms of operation, when the valve handle is turned to the open position, the ball rotates to where the port through the ball moves in line with the valve body inlet and outlet. When the valve is shut, the ball is rotated so the port closes the flow opening of the valve body and the flow is stopped. There are disadvantages related to instrumentation ball valves. The ball design offers relatively poor throttling characteristics. The throttling position can lead to rapid erosion due to the seat's exposure to high-velocity flow. They are not suitable for slurry applications, as the entrapment of particles in the valve's ball and seats leads to wear, leaks, or failure of the valve. However, there are several advantages to using instrumentation ball valves. They are readily available and offer a large variety of sizes, shapes, combinations, and materials. They are generally the least expensive of any valve configuration. They also carry low maintenance costs. Most ball valve actuators are of the quick-acting type, which only require a quarter turn of the valve handle to open and shut the valves. This design makes visual indication of flow a viable option. They are compact in design, they do not require any lubrication, and they provide a fluid-tight seal with relatively low torque administered. There are many similar varieties of instrumentation valves. One example, the instrumentation needle valve, is similar in many aspects to an instrumentation ball valve, but uses a long tapered needle, sometimes referred to as a plunger, to regulate flow. There are many varieties of instrumentation valves and many different applications in which they are used. For these reasons, care needs to be taken to properly identify the right connection to create a safe and leak-resistant seal.